In this video, we'll look at how to use algebra tiles to complete the square. So we're going to start with this expression here, y equals x squared plus 2x plus 3. The goal here when we do this is to convert from standard form to vertex form to help us figure out where the maximum is. So we'll go ahead and do that. We're going to do it, instead of doing it algebraically, we'll do it with the algebra tiles. So first off, we're going to start with an x squared. We also need 2 x's. And then we need 3 1's. So we'll drag out what we need. And the goal is to make a square. It is called completing a square, so we actually try to complete a square. And the way that we complete that square is we're going to take our x squareds and our x's and form a square. You'll notice that the only way we're going to make a square is if half of our x's go along the one side of the x and the other half go along the other side. So you can see here we are about to complete a square. Notice the 3 1's are kind of sitting off on their own. We're going to leave them there for now, and we're going to actually complete this square. So to complete the square, I needed another 1. The trouble is, when I add in this 1, I'm changing the value of my expression. I just added in a 1, so instead I'm going to add in a 1 and a negative 1, which gives me 0. But I'll split that 0 pair up. I'll have a positive 1 here, and I'll just bring this negative 1 up over here. And so when we complete the square, you can see that we end up with an x here and a 1 over here and an x here and a 1 over here. Obviously it's a square, so the dimensions should be the same. These are both positive 1's. So we end up with y equals x plus 1 all squared. And then we've got some stuff left over here. Well, this gives us a 0 pair, and we're only left with 2 more, so we get plus 2. So we've just completed the square, and we can now figure out where the vertex is. Let's look at what happens if we have a negative number or some negative numbers in here. So again, we need an x squared. We need negative 6 x's. Let's grab out the negative x's, and we'll make some copies here. I copy that, whoops, once, and then one more time. There we go. All right, so remember our goal, oh, sorry, and we also need negative 3 1's. Let's go ahead and grab out the negative 1's. Make 3 copies of that. Okay, so our goal again is to make a square. So if we're going to make a square, we need half of our x's here on the one side of the square and the other half on the other side. You can see that the whole process for completing the square, where you take half of the x term, you can see where that's coming in now because we are literally trying to make a square. All right, we need some values down in here in order to complete this square. Don't forget, this is negative 3 in this direction and negative 3 in this direction. So the area down in here will be a negative 3 times a negative 3, which will be positive 9. I'll drag out those 9, but sometimes what happens is students decide that there's a faster way to do that, and they just draw a box that represents 9, which also is okay. All right, let's copy this. I thought I copied that. There we go. And we'll just drag those into place so that you can see our square. So the important part here, though, is that we just added 9. Oh, I can't quite get to those. We just added 9, and that changed the value of our expression. So what we also have to do is we have to take 9 away. So I'm going to just copy these and negate them. So that's sitting out here with our other 1's that we had over here, which actually works out quite nicely because we actually get a nice little rectangle there. All right, so what are our dimensions? Well, our dimensions of our rectangle now are x minus 3. So this expression is equal to y equals x minus 3 all squared. Well, let's try that again. I think I broke my pen somehow. Let's try that over here. So this is y equals x minus 3 all squared. And then we have this extra stuff as well, which I think works out to minus 12. Yeah. All right, and now you might ask, well, what happens if there's a coefficient in front of the x squared term? Well, that just means we need two copies of this. So let's go ahead and do this. We're going to do the exact same thing, but we're actually going to have two squares. So I'm going to make a square here, and I'll make another sort of equivalent square down here. Hopefully there's enough room to do this. And I need 8 x's in total. Half of them go to each square. So this is where you do the factoring part. If you were doing this algebraically, what do I need? I need 8 of these, so we'll just make a few copies of these two. Copy that. There's. If I were smart, I would have copied the 4, but that's okay. All right, so half of these, 1, 2, 3, 4, 5, 6, 7, 8, half of them are going to go with our second square, and half will go with our first square. And again, we're trying to make a square with each of these, so we'll take half of our squares and put them along the bottom, half of the squares along the side. And I haven't added in the -5 yet. I should probably do that before we get too far into this. Before moving on, we'll do that. All right, there was also a -5 here. Again, we'll just leave that off to the side. So 1, 2, 3, 4, 5. All right, and in order to complete our squares, we need 4 ones. And we need those 4 ones in both squares. So I'll just copy that and add it down here. Except when I do that, I've now just added 8 to the expression. I added in 4 ones at the top, I added 4 ones at the bottom, so I actually need to also add in 4 negatives for each of those. So I'll just make a copy of that, negate it, and then we'll make one more copy of that. So what does this look like then? Well, we have our 2 squares that each have dimensions of x plus 2. Sorry, that's not looking so good. So our 2 squares, so we have our y equals, and we have 2 copies of this x plus 2 all squared. And then we have all of these extras here. So what's that? -8, and then 5 more that we started with, so we're at -13. And again, really easy to read the vertex off there. So that's how we can complete the square with the algebra tiles. Really makes it meaningful for students to see what's going on and the fact that they're actually making a square.